In order to be able to carry the data across the 5G radio access network, the data and the information is organized into a number of data channels. By organizing the data into this number of channels, the 5G system is able to manage the data transfer in an organized and ordered fashion. And the system at this time will be able to understand the data received, and hence it will be able to process it in a correct way. Also, the need for data channel is because there are many different types of data that needs to be transferred, either the user data and the traffic that need to be transferred, or the control information which are needed to manage the radio communication link and to help send and receive the data correctly, and also support the proper delivery of user data. Also, there is a need for data to provide synchronization, to provide access, and also to provide many other reasons for data to be transferred. So as you can see, all of these uses of the channels are mandatory and require the transfer of data over the radio access network. If you look back and you can remember the LTE protocol stack, you can notice that from the figure or the diagram on this slide, there are many similarities between the LTE protocol stack and the 5G new radio protocol stack, because the LTE protocol stack is being taken as a basis for the development of 5G new radio. The 5G new radio user plane is containing physical layer, MAC layer, RLC, and the BDCP layers, as we will see after, same as the LTE or long-term evolution. And it has introduced a new layer named SDAP, Service Data Application Protocol, which we will explain after in the protocol stack section. On the other side, the control plane of the 5G new radio layers, it will be almost identical to the LTE. So besides the main functions that each layer is performing, we can see also that the physical layer is offering to the MAC sublayer transport channels, and on the other hand, the MAC sublayer is offering the RLC sublayer logical channels. So let's start with the 5G new radio layered architecture and try to explain the different layers and what functions they are performing. First, we have the physical layer, and the physical layer is responsible to handle some functions. For example, the error detection on transport channel and indication to higher layers, encoding and decoding of transport channels, rate matching of the coded transport channels to physical channels, mapping of the coded transport channel onto physical channel, modulation and demodulation of physical channels, frequency and time synchronization. Also, the physical channel is responsible to perform the multiple input, multiple output, or the MIMO antenna processing, the beam forming, and finally the RF processing. The second layer of the protocol stack of 5G system or 5G new radio is the MAC layer, which is the media access control. And the media access control layer is performing many functions and many services. We can mention some of them. So the MAC layer is providing many functions like the mapping between logical channels and the transport channels. It also provides multiplexing and demultiplexing of MAC SDUs belonging to one or different logical channels delivered from the physical layer on transport channels. The MAC layer also provides priority handling between user equipments by means of dynamic scheduling. And lastly, the MAC layer is providing priority handling between logical channels of one user equipment. The third layer of the protocol stack of 5G Neo Radio is the RLC, which is the radio link control layer. And the radio link control layer, or RLC, is providing many functions and many services. Some of them are the transfer of upper layer PDUs the sequence numbering, the error correction, and segmentation and resegmentation. So now we can explain what are the different types of channels we have and what are the specific function for each one of them. As we mentioned, we have three layers: the physical layer, the medium access control layer, and the radio link control layer. So we have three types of channels. The first type of the channel is the physical layer channels. And for the physical layer, you will see that the channels, the physical layer channels, are similar to the 4G LTE channels, but two channels have been removed, which are the BHICH channel and the BCIICH channel. As you can see on the left hand side of the screen, we have 6 physical channels. The first one is the physical downlink shared channel, BDSCH, and the 5G new radio physical downlink shared channel, BDSCH, is carrying the data sharing the capacity on a time and frequency basis. Then we have the physical downlink control channel, BDCCH, and from the name you can see that the 5G physical downlink control channel carries downlink control data. Then we have the physical broadcast channel, BBCH, and this channel is part for the synchronization block, and its function is to provide the user equipment with the master information block. Then we have the physical random access channel, BRACH, which is used for channel access as it transmits an initial random access. Then we have the physical uplink shared control channel, or BUSCH, and this channel, as you can see, is the counterpart of the BDSCH, and it is used to carry the data from the uplink and its higher mapped channels on a frequency and a time shared basis. And the last physical channel we have is a physical uplink control channel, BUCCH, and this channel is carrying the uplink control data. The second type of channels we are having is a transport channel, and the transport channel is defined by how and with what characteristics the information is transmitted over the radio interface. So we have 5 transport channels. The first one is the BCH, or the broadcast channel, and the broadcast channel is used for the transmission of BCCH system information, or more specifically, the master information block. The second type of transport channels is the paging channel, PCH, and from the name, this channel is used for transmission of paging information from BCCH logical channel. The third channel of transport channels we have is the DLSCH, or the downlink shared channel, and this channel is the main transport channel used for transmitting the data of the downlink over the new radio. It is supporting all new radio features such as dynamic rate adaptation and channel aware scheduling. The fourth channel of the transport channels we have is the counterpart of the previous one, which is uplink shared channel, or ULSCH, and this one is used for the transmission of uplink data. The last transport channel we have is the random access channel, or RACH. Although it doesn't carry transport block, it is classified as a transport channel. The last type of 5G data channels is the logical channel, and as we mentioned before, the MAC layer, or medium access control layer of the new radio, is providing the services to the radio link control layer or RLC layer in the form of logical channels. And the logical channel is defined by the type of information it carries. So either it's carrying a control in channel or traffic channel. We can list some examples for the logical channels and we can see what is the function of each one of them. The first channel we have is a BCCH or the broadcast control channel, and the broadcast control channel is used within the downlink, and it is used as per the name for sending broadcast style information to the user equipment within the cell. The second channel is the paging control channel PCCH, and this channel is a downlink channel and it is used for paging of the user equipment whose location is not known to the network. Then we have the common control channel CCH, and this one is used for the uplink and for downlink for transmission of the control information to and from the user equipment. And the last channel of the logical channels we have is a DTCH, dedicated traffic channel, and this one is also existing in both uplink and downlink, and it is dedicated to one user equipment and used for carrying the user information to and from a specific user equipment and the network. So, as you can see, the mapping of the logical channels to the transport channels is done by the MAC layer as part of the multiplexing and demultiplexing function of the MAC layer. And you can see on the left side of the slide, we have two parts. The right one is for downlink, and the second one or the left one is for uplink channels mapping.